Welcome to the NTW2025 DevSecOps Foundation. I'm happy to welcome you all today. We're excited to have you join us for this insightful session. I would now like to introduce our trainer, Mr. Ramesh Alwan, who will be leading today's class. Mr. Ramesh, over to you.
Thank you, Gigi, and good afternoon, everyone, and welcome. Welcome to this session of DevSecOps Foundation. The session will last approximately between 60 to 90 minutes, depending upon how interactive you guys are. So without much ado, let me quickly start off with a quick introduction about myself, and then we'll proceed with the class. Let me share my file first. All right, if you look at the agenda, I'll start off with an introduction. We'll learn what is DevSecOps, why do we need DevSecOps, what is the difference between DevOps and DevSecOps, what are the core principles, security as a code, the DevSecOps process, the DevSecOps security tools in DevSecOps, security gate checks and approval processes, what is the collaborative culture that you need to practice to implement DevSecOps, how do you do continuous security validation, implementing DevSecOps in your organization, what should you do? I mean, this is an overview session, so we won't go into much detail. Then measuring, how do you measure success? We will not go to a case study typically because case study itself will go for about 2 hours. Then we'll have a Q&A and wrap up in case there's any questions. That's pretty much what the agenda looks like. With that, so that's me. My name is Ramesh Alwan. I hold a postgraduate degree in computer science and applications. I come with about 43 years of experience overall. I'm a retired Indian Air Force veteran. I used to work on the MiG-21s and 23s. I've been in the IT industry for well over 30 years, and my association with Malaysia has been very good. I lived in Malaysia for about 2.5 years, 2015 to 2017. I was running the IBM Global Delivery Center out of Cyberjaya. It's a pleasant experience, lovely country, and I will never forget my experience back in Malaysia. So a great experience there. I've retired from IBM. My last job was with IBM. I retired from IBM in 2022. And since then, I've been training. I'm a freelance trainer. I've so far trained about 4,000 plus candidates in different streams. I'm a certified trainer by the DevOps Institute in the US, in DevOps Foundation, DevOps Leader, DevSecOps Foundation, DevSecOps Practitioner, SRE Foundation, SRE Practitioner, Observability Foundation, AIOps Foundation. Besides this, I also do a lot of tools training. I am also a certified business relations management training. I do a lot of consulting in the areas of tools optimization, failure testing, chaos engineering. Then I also help clients implement tools. I help clients build new architectures. I help clients in modernizing their applications, migrating them to different clouds. I'm also a certified cloud practitioner in AWS. So that's a quick rundown about me. Long history, work history, started off with Air Force, then moved on to Wipro. From Wipro, I moved on to Citibank. From Citibank to GE, General Electric. From there, I moved on to PwC. Then to IBM for about 20 plus years. That's a quick history about who I am. And let me start off with the session. There's a disclaimer that I want to call out. We will be talking about some of the tools here, right? I will name quite a few tools here as we move forward, right? Now, that does not necessarily mean that I endorse these tools. I mean, every individual, every environment will require a specific set of tools. So it depends on the environment, the individual preferences. So what tools I kind of talk about here are tools that I normally use. So it necessarily does not mean that you have to use that tool or I recommend using those tools. That's the first. That's a disclaimer that I thought I should bring up right up front. And then from a DevSecOps standpoint, we will start off with what is DevSecOps. Security as a shared responsibility, shifting left, collaborative, automated, adaptable, ultimate time, a lot of great English out there. But let's go one by one quickly. Security as a shared responsibility. We all talk about this in every company that you work for. There is a common saying that says that security is everybody's responsibility. Don't think that if you have a security team, only they will be in charge of security. Security becomes everybody's responsibility. Everybody is accountable for the organization security, be it information security or physical security. For instance, when you swipe your badge in and get into your office, if somebody is tailgating you, as a good Samaritan, you're supposed to turn back and tell that individual, please do not tailgate, swipe your badge and come in. So that's what we mean by everybody becomes responsible from a security standpoint. Shifting left, integrating security from the start. There's a very famous statement that says that shifting left and accelerating right. What that basically means is if you look at the software development lifecycle, it starts off with requirement gathering first, where you gather requirements, and then you design, create a design out of the requirements. The design could be a high-level design and then a low-level design. The design will get converted into a bill of material in terms of how many people do you need, what tech stack you will use, and all of that. What licenses do we need to purchase, what infrastructure is needed, all of that. Once that is all in place, you start coding. The development actually happens. You start coding. The coding will be followed by testing. The testing will be followed by integration testing, which means you're getting into a CI/CD mode. You're getting into a continuous integration mode. Again, you will do some testing. Then you get on to staging, where you'll do more testing, functional, non-functional testing. From there, you move on to the production, where you will basically deliver, deploy, and then finally do a release. The release could be manual or automated, depending upon what the organizational priorities are. So in this whole software development lifecycle, what happens is, generally, in a typical waterfall kind of environment, you developed everything, then you call the security to find out if there are any vulnerabilities. What happens is they find about 10 or 12 or 15 vulnerabilities. They tell you these have to be fixed before you can go live. So your go live date typically will get pushed because you have to fix all of those. And what ended up happening was that a lot of us came back and started blaming, saying that, oh, security is becoming a roadblock. Every time there's a release date, they come in at the last moment and they say these things have to be fixed. But if you look at the actual problem, the problem is not with the security team. It is with us, right? We don't get involved security upfront. We involve them right at the fag end, because of which we see those delays. So the best way to address this issue is shifting left, which means that don't bring security at the end, but bring security right at the design phase, which means that they can help you design an application's architecture that will have less vulnerabilities or no vulnerabilities. And they will also help you build what is called a threat landscaping. They will tell you what kind of libraries to be used, how much of open source can be used. All of that knowledge, all of that intelligence will come in from the security people, provided you bring them left. So left, right is nothing but extreme left is where you start off with a requirement gathering, then designing, then bill of material. So left to right, when you move, the leftmost step is requirement gathering. The rightmost step, after you release, you actually get into operate, manage, monitor, and then report. So the rightmost step is called reporting. So security used to come just before release, which is far right. So you have to move them left, means you bring them earlier in the life cycle of the software development life cycle. That is what they mean by shifting left. So integrating security from the beginning. Collaborative, automated, and adaptable practice. What that basically means is, right from the design phase, work along with the security team. The development team, the operations team, and the security team. All three teams have to work together hand in hand collaboratively to make sure that you're able to deliver, build an application or build a set of infrastructure and deliver to your customer seamlessly and securely. The ultimate aim is faster delivery without compromising on security. Now, most companies earlier thought that, oh, security, we will just, we'll fix it later on, but let's first release it, right? Security was probably a low priority item earlier, 20, 25 years back. They said, let's first release and then we'll fix it. But those were the times when, cyber threats were very, very less. But with the proliferation of cloud, with the proliferation of technology, containerization, microservices, distributedness, you name whatever you want to name it, right? The amount of cyber threats that have come up into the environment is pretty large, very huge. So it is so important for you to make sure that you start addressing it right from the beginning. So the point is, you will need faster delivery. That we cannot compromise, but you will do faster delivery without compromising on the security. That is the essence that we need to understand. Why do we need DevSecOps? Pricing cyber threats and data breaches. I just spoke about it, right? With the cloud proliferation, with advancements in technology, data breach is happening. You have hackers who can hack into your environment at will. They don't need your permission. They can just get into your environment, do what they want. That is how intelligent today people are, and not just intelligence with people. That is how technology is capable of. With all that, you need a framework like DevSecOps that can make sure that it can help you build a threat model around which you start building your controls, and within the controlled environment, you build your software, which is that rather than building an application and then bolting security at the end, all you're saying is build your features securely right from the beginning. Use the right standards, use the right coding standards, use the right quality, use the right tools, use the right libraries. Make sure that you don't do too much of open sourcing. We're not saying open source is bad, but you must know how to build controls around the open sources that you're using. That's a big, that's a big gap today in a lot of development teams where they understand how to use open source to build applications, but they're very ignorant in terms of how strong the controls should be around the open source that they're using. The second bullet is security after delivery is less effective. The moment you ignore security and you've gone to delivery, you start building it, it becomes ineffective because you've already opened up a lot of conundrums, right, in your software. You have left a lot of vulnerabilities that have not been that's not been fixed. So what happens is, you are in delivery, and for you to a runtime going back and fixing, today it is possible. But 5-7 years back, if somebody were to ask me, Ramesh, can we fix vulnerabilities during runtime? I would have said no. But today, yes, there are tools that can. There's a tool. There's a segment called RAST, runtime analytic security testing, where you can actually test and fix issues and bugs. So, but it's a complex task. It's a very complicated affair to do that. So why get into all of that? Why can't we bring security upfront towards the design phase? Make sure that you're building your features safely and securely. The third bullet talks about operations and security in bottlenecks. Generally, what happens is when security team comes in, the operations and development teams, they start talking about, oh, no, not now. Security, stay away. Let's complete the build and you then come back. So what they think that security is becoming a bottleneck. On the contrary, look at it from a security standpoint, an operations team standpoint. If they're not let into the design or the build phase, they will have a problem during the delivery. So their biggest bottleneck today is the development team. So that's exactly why we need DevSecOps, which ensures that security and operations are part and parcel of the design phase. Rising penalties for non-compliance. Now, so today there is a lot of there's a lot of regulatory bodies that say that if you don't comply with certain norms that the regulatory bodies put in place, there's a huge penalty. For instance, let's talk about one industry, pick one industry, healthcare. Healthcare is governed by HIPAA. HIPAA is a regulatory norm, a body that says that in any application that runs in a healthcare environment should adhere or comply with the norms as laid down by HIPAA. Go to fintech or finance, banking and finance, you have something called a SOX compliance. GDPR is a global data privacy rights, which is protection rights, which means that regardless of what industry your application runs for, it should make sure that the data, privacy of the data is all maintained. Just give me 1 second, please. Regardless of which industry your application runs, the data privacy rights must be maintained. So there are different standards laid down by different regulatory bodies. Now, globally, it's a mandate that if you don't comply with the norms laid down by these regulatory bodies, you could end up being penalized heavily. Now, every time, whenever they revise certain standards within their regulations, it is important for IT organizations to go back and look at if the current application is adhering to the new norms. They will send out a notification. If it is not, you may have to go back and make changes in your code. It will become a new release for you. It's a whole new process that we need to do. Now, I've had, in my consulting assignments, I've had companies ask me, Ramesh, why should I do this? This is spend for me. I said, you don't spend $100 now, you end up paying $100,000 as penalty. So better be prepared. It's two options. One is penalty. Second is your system remains completely vulnerable to hacks and threats. So that's why we need DevSecOps that can emphasize. In fact, I would use a very strong word called impose restrictions and controls around how you operate your environment. The difference between DevOps and DevSecOps. DevOps, now look at the left, first column talks about what is the primary objective of DevOps and DevSecOps. What are the security considerations? What do you mean by collaborative team in the context of DevOps and DevSecOps? And lastly, what are the automated practices? Let's look at the differences. So the first primary objective of DevOps is release faster and more frequently. So DevOps, this term is called velocity of releases, right? In DevOps, you have this term called velocity of releases, which means how fast do you release new features to your customers. Similarly, in SRE, you have wisdom of production, which is that how much knowledge you gain in production by failure, that wisdom you pass it back to the developer. That's why it's called wisdom of production. In DevSecOps, you release faster and more frequently without adding vulnerabilities, which means that you don't, as you keep on releasing new features, make sure that you're not adding more vulnerabilities. How do you add more vulnerabilities? As you develop, every time you release a new feature, it means that you're adding more code into the software. And every time you add new code, you could end up using certain libraries, that might have vulnerabilities. If you've not checked, if it does not pass through your checking mechanism, control mechanism for vulnerability, then you're actually leaving your software open for vulnerability. So the point is, in DevSecOps, like DevOps, you release faster and more frequently, but without compromising on security or adding vulnerabilities. Security considerations. Security is a separate lateral pipeline. Remember, I told you before, in waterfall, even in an agile model, at one point in time, we brought in security very late before we delivered or before we released. Whereas in DevSecOps, security is integrated from start to delivery. Security becomes part of the design team itself. Collaborative team, developer and operations. In DevOps, it was Dev and Ops. In DevSecOps, it's Dev, Ops, and security. In automated practices, DevOps talks about continuous integration and continuous delivery and deployment. In DevSecOps, it is continuous security validation and governance, which means that you will do CI/CD in DevSecOps, but you will add security validation governance to it. That's all. So you will have what you see in that continuous integration deployment. Along with that, you'll have continuous security validation and governance as well. Those are the key primary differences between DevOps and DevSecOps. Core principles, security as a code. Now, security controls automated alongside application code. Now, I'll give you an example here. Look at the right. Let's say you're developing a web application with Terraform to deploy it in AWS. Your application stack might include EC2 instances, a load balancer, and a security group. Instead of manually configuring your security groups after your application is deployed, you describe them as code alongside your application's Terraform code. So every time you start coding in Terraform, you also code your security code. You bring in your security controls as a code alongside. That's how you will bring in security controls alongside your application code. Now, in fact, I'll show you. I think we'll have to quickly diverge a little bit and look at one small diagram that I really wanted to share with this team. Let me bring that up. So this is a book of security DevSecOps architecture. It's got about 70 different architectures that you can use, right? Look at this. This is called security hooks. At each phase, right? In the plan phase, you will capture security requirements. In the coding phase, you will do secret detection and leak prevention. In the build phase, you'll do source code analysis, or software composition analysis. And then during the test phase, you'll do security testing. In the release and deploy phase, you'll do vulnerability management. That's like a SAST scan. You'll do a DAST scan, artifact scanning. In the operate and manage, you'll do security testing, operational security metrics. There's a whole lot of things now all of this means that during the design and build phase itself, you actually bring in security. which is called security. Bring in security hooks so that your software itself gets built very securely rather than adding security right at the end. So in this case, what you do is when you build an application in Terraform, you also start coding your security control so that along with your code, the security controls code also is lying alongside that. Now, what this does is this lets you enforce your security controls at deploy time and repeatable automation, which means that if you have a code running, every time you deploy, the security code will automatically run to make sure that there are no vulnerabilities that are let out. Let's see when you do this, what is the benefit? Security controls are implemented as a code alongside application code. You don't have to bring in security at the end. Controlled by version control. Every time you change version of the software, obviously you'll also make sure that the security codes also change. You can track and audit it. Automated as part of the CI pipeline, which means since you're putting it with Terraform and you're applying policy checks, this will also make sure that every time there's a change, it also the security coding also gets changed. Consistent and repeatable across environments. So whichever environment you go and deploy your code, the security controls will also go along with that. You don't have to build a separate security control there. Finally, scales safely with your applications grow. So as your application grows, the security control will also grow. That's how you'll build the whole thing. So one of the core principles is security controls automated alongside application code. You must make sure that the security controls are coded along with your application code. Security policy enforced through code reviews. Every time you do a code review, there must be a separate section for security policy enforcement, which means that when you do a code review, you'll also look at what are the security norms that you've adopted. Is your code standard complying with what HIPAA says, SOX says, or any regulatory body says? Does it comply with all the organizational policies, security policies? That also has to be done. That's the second thing. Collaborative approach to define and manage controls. So you must bring in the development team, the operations team, the security team together so that you can decide. The ops team will tell you, no, I don't need a control here because it will slow me down. Can I shift this control one phase later? The security will then advise what to do. Dev will say, no, if I put security hooks here, my database might hang. So that's a discussion that needs to happen between security, ops, and dev. There should be a collaborative approach to define and manage where control should be placed, how it should be managed. Lastly, easily auditable for compliance. Your code, your application, your environment must be easily auditable for compliance. Anytime anybody wants to audit, it must be, you must allow them to go back and audit. It must be very easy to come back and audit for compliance standpoint. The DevSecOps process. Now, if you look at it from a process standpoint, DevSecOps stage, this is a very simple slide. We've done it in about a minute. It just starts with, I told you, planning. In fact, I would say plan. After plan, there's a design. After design, there's a BOM, bill of material. Then you develop, then you build. The difference between develop and build is develop is coding. You will have multiple groups of developers coding in their own branches. All of these code will get merged in a main branch, maybe in Git or any of the repositories where you do version controlling. And once it is done, you create a build for an integration testing. With it, you bring in all the small pieces of code that different developers have written, put them in one bundle, and you create what is called a build. The build then gets tested with security integrated. You also test for, you use a SAST methodology to test, static analysis security testing. And then after testing, you do a pre-prod, then a release and a deploy. Then you'll monitor and repeat. The whole step repeats. So this is a typical DevSecOps process, which is plan, I would say plan, develop, build, test, release, deploy. The other way around, deploy, release, monitor and repeat. Security tools in DevSecOps. Static application security testing, that's called SAST. Example is Sonar, Cube, SemGrep. These are some, there are a lot of tools in the market, but there are a couple of examples that these guys have given, right? The most important one now, when the code is not running, you've just finished coding, you will generally do a SAST and an SCA, software component analysis, or it's called a software composition analysis. What does your software contain? That's a software composition or a component analysis. What components have you used? What libraries have you used? How have you declared your variables? What is your coding standard? What is your coding quality? All these aspects will get checked by the SAST and the SCA tools. A few SCA tools that they named is Dependabot and Snike. Container security. There is something called a DAST, which will come in a minute from now, container security. If you use microservices architecture and you have containerized your application, you'll use Anchor or Twistlock. Then SIEM, which is Security Information Event Management. This comes during monitoring the application for its performance. We call that as APM, Application Performance Management. You use tools like QRadar or Splunk. In between, there is also something called a DAST, which is Dynamic Application Security Testing. Then there's something called an IAST, which is Interactive Application Security Testing. There is something called RAST, which is Runtime Application Security Testing. So the difference is static is when the code is not running, dynamic is when the code is running, RAST is also when it is running. IAST is you send a command to the application and you expect the application to respond with a response that's called IAST. So there are different models, methods that you use for testing, and different tools come in place for each other. In fact, there'll be one slide that I will try and show you before we leave in terms of what are the different tools that we get. In fact, I must have a slide on this, and I'll show you from the architectural book that I just shared with you. Security gate checks and approval process. Now, remember, whenever you build something, you typically have something called a toll gates. The toll gates are nothing but after every phase, you will make sure that there is a checkpoint. It basically that before it moves on to the next stage, you will say that this is a checkpoint call where I decide everything up to here has been met with. So that's called a toll gate. So security gate checks and approval process, nothing but it's like a toll gate where you come back and check, have I met all the security norms until here? If yes, I move on to the next phase. If not, I go back and fix that. Now, provide fast feedback to engineers. The agile iterative method of providing feedback to engineers so that they can go back and fix issues faster. I'm sorry. Implement fallback or gate mechanism for high-risk code. So what you do is, wherever you think the code is extremely risky, in fact, the kind of libraries that you use, let's say you're under compulsion to use a specific set of libraries that you know are not the best ones, but because of a specific requirement, you have to go back and use that, which means that you are you're putting your code in a high-risk zone. So there, the gate mechanism helps you to fall back on control, saying that, okay, we know that this is a need-based use, but what kind of controls are in place? So you'll create a set of standard controls that will need to be put in place. You will do extensive testing whenever you think your code is in a high-risk zone. So these are the different gates, checks, and approval process that you will put in place to make sure that your code is completely safe and secure to be run in an environment. Collaborative culture. Security is everyone's responsibility. We spoke about this before. Security is everyone's. Everybody has to. You want to make sure that everybody takes care of security within the organization. It is not one person's responsibility. Security team assists, not obstructs. I'm so sorry, guys. I've got a bad throat. So security is everyone's responsibility. The security team assists, not obstructs. So what we need to understand is the security team does not obstruct moving forward with the deployment. In fact, they only assist in making sure that we are able to deploy our software, our service, our product on time without compromising on the security. Collaborative reviews and knowledge sharing. Every time you talk about collaborative reviews, it is important for us to understand that the development team, the production team or the ops team, and the security team come together, perform a review at every stage, right? After build, after test, after stage. You do a collaborative review and share your knowledge of what do you think has gone wrong? How do you go back and fix that? continuous security validation. Now, before we do this continuous security validation, we have to look at the tool so that we can come back and understand how do you do continuous security validation. Let me just pull up the document. Yeah. So if you if you typically look at it, for each of the phase within the development lifecycle, for planning, you will do a security test plan. You will use a security, which is a SAST here. Right? For coding, you will use Git. That will probably give you version controlling. You'll use Artifactory to store artifacts, linters and unit testing. You'll probably also do some unit level testing or a code level testing during the coding phase. The build is when you build for integration. Integrate testing. You will again do static application security testing here, or a software composition analysis or a software component analysis. You do that. This will typically tell you in this phase when you do a SAST or when you do an SCA, it will typically tell you whether your entire code is safe, what quality has been formed, what quality has been observed. What quality has been followed, what norms have been followed, what controls are in place, where have the controls been placed, what kind of libraries have been used, how risky they are, the controls that you have put in place, are they sufficient enough to counter the vulnerabilities that your software has? Everything gets tested here using a SAST or a SCA. The SCA will give you a very detailed analysis of what all has been put in place. How do you really go back and make sure that the software does not become vulnerable? Once you do that, you move to test phase. In the testing, you're basically running your software, right? So where you do a dynamic application security, like a SAST, you'll use a DAST here. The DAST does nothing but when the application runs, see, there are two parts to it. One is within the code, are there vulnerabilities? And then when it is running, is it creating? So when there are different service calls happening, when the application is running, there are different service calls happening. Now, when those service calls happen, what protocols do they follow? What calls do they make? Does it expose any part of the software? Does it create any new vulnerabilities that have not been identified by SAST? So that's what will happen during DAST. DAST is something you play that during integrated testing. Now, the moment you have certain observations are there, you go back to the coding, right? The point is when you code and you do a unit testing, if there are issues, you go back to the planning phase, right? Fix it, address them, then come back to coding again, recode, again do unit testing. Unit testing is passed, go back to the build phase. Then once you finish the build, you do a SAST testing or an SCA testing. There are issues, you go back to code and fix it. If not, you move to the test phase. Integrated testing. After build, you don't integrate. When you do an integrated testing, you run a DAST. The DAST throws out errors or problems or issues. You go back to the build. Again, what you do is you identify which part of the build has got a problem, go back to the coding, get it fixed, come back, do another static application testing. If it passes, go back. So it's a kind of iterative process. What happened earlier in the waterfall model was you came almost until here. At release, you brought in security. Security will test and give you 20 observations. You go back all the way to coding. That is not the most efficient way because you did this, you did this, you did this. You're not doing any security testing here. You're just doing a normal functional testing. So within testing, you do two types of testing. One is called functional testing, which is, a test for the functions of the software or application, where you understand if the software or application that I built, is it delivering what it is supposed to deliver from a client standpoint? If it does not, what are the features that are missing? What is it not delivering? I have to go back and fix that. But then the non-functional testing could be regression testing, could be load testing, could be security testing, all of that, right? So in olden days, you probably did not do a lot of non-functional. You probably did a non-functional testing more from a load testing or regression testing. Security testing was very, very lean in olden days, but today in modern days, DevSecOps coming in, you have implemented security right from the beginning, so everything gets tested here. So finally, at the DAST, when it passes DAST, the dynamic application security testing, you go back and deploy and release it. Now the release deploy, you're releasing it to be deployed. And once you deploy, there is a flip switch. We call it as a flip switch where you flip it for users to start using. At deploy, what happens is it is here, not ready to be used. You have to just lift this gate and then users can start connecting to the software. The point is, the moment they start connecting, some enterprises also run something called a runtime tests, runtime security testing, to see in real environment, whatever you did here, that was not real. You're just in a test environment. In real environment, you go back and test using maybe a runtime application security testing, which can tell you, are there errors or vulnerabilities? So you start monitoring the logs to understand other vulnerabilities that are getting thrown out. For the first few days, there's a lot of emphasis on you going back and monitoring the logs to understand, are there any new vulnerabilities that the software is throwing, application is throwing, while it is running in production. If it is, and if it is not coming in the way of production, some enterprises take it right back to code to go back and check what is causing those. Again, follow the same process: code, unit test, passed, build, integrated testing, SAST, come back, then DAST for integrated, everything passes. You release that as a new version, a new feature. Software. That's how you go back. Basically, it's a life cycle that it goes. For each of these phases, there are a lot of tools that you can come back and look at in the market. Now, again, depending upon the environment that each one of you work in, what kind of IT environment do you have? Do you have development, testing, staging, production separate? What kind of control do you have in place? What is your security? There's a lot of ifs and buts that you have to go through to understand what tooling is recommended for your organization. So now once we understand this, we come back and start looking at how do you continuous security validation. To do this, remember I told you right from planning phases, you will have to validate at every step, saying that, is my code safe? How safe is my code? Right question, how safe is my code? So at each phase, you use different sets of tools, different sets of programs to run your code through and understand if it really is safe. Does it possess adequate controls using which it makes sure that your system is not vulnerable. Now remember, the moment your application becomes vulnerable, guys, the point is it can lead to a myriad of things, because you're telling hacker that, hey, my door is open, please come in. I'm vulnerable. You can hack into me without a problem. Please come and steal my data. That's exactly what you're doing. You're opening a floodgate, letting hackers to come in and steal data, do anything with your system, and then put a ransom on your head. This is, if you go talk to a CISO, a Chief Information Security Officer, or a Chief Information Officer today, they will tell you one thing. If there is one thing that keeps them awake at night, it's just the vulnerabilities. How vulnerable are my systems? Because it is not that we have done a bad job of building an application or putting up an infrastructure. It is because technology is progressing at such a fast pace. What you did yesterday can be countered today. Hackers are becoming more and more. They're about 2 or 3 steps ahead of you. You build one control, they've already decided how to break that control. So we are always lagging behind the hackers. That's the actual scenario today. Right? So what you do is security regression tests alongside functionality tests. I just spoke about it, right? The security, one of the non-functional tests they do is regression testing. Regression is just making sure that after every time, let's say you find a vulnerability, you go back and fix it. The fixing means that there is a change in the code. The moment you do a change in the code, it means that it could have thrown open more vulnerabilities. So you come back and test. Regression testing is continuous, constant testing of the code every time you make a change to the code. That's called security regression testing. Now this is alongside. So every time you check for functional, something is wrong, you go back and fix that code for delivering the function. Again, you'll do a security test. So it's a constant cycle that you'll have to follow to make sure that you're consistently validating security. The second bullet talks about security vulnerability scanning for each new code deploy. Every time you bring in, it could be one line of new code. Sorry, one word of new code. Sorry, one letter of new code. It'll go through the whole process. That's a new build. Nice. So you'll have to do the SAST, you'll have to do the DAST for integration testing, and you probably have to do a RAST and YAST. Right? So every step has to be followed. Every time the code goes through a change at whatever level, it could be a minuscule level, large level, whatever change. Now, remember, a professional organization will make sure that regardless of the size of the change, they will mandatorily follow the change management process. And the change management process will make sure that part of the change management process should also make sure that your security vulnerability scanning, security vulnerability testing, everything gets done before it gets released into production. If that is not there, then you have a big problem in the whole process. You will have to sit down at an organizational level, start looking at how do I fix my process? I don't have a good process in place today. And how do you know that? Every time you have a security hack, every time you have a security incident, you know that you are a very weak organization. People can just hack into your system just like that. The last one is continuous vulnerability assessments and penetration testing and staging.
Asian country produce 50% discount.
Sorry, somebody's talking. Can you go on mute, please? Okay. The last one is continuous vulnerability assessment and penetration testing and staging. Now, remember, I told you the different phases: development, testing, staging, production. We finished development, testing, and now in staging, right? So what do you do in staging? Staging is like production. So whatever tests you want to run in production, you actually do a copy of that in your staging to make sure that when it goes to production, it is doubly tested. That's exactly what staging is, right? Now, in the staging environment, what you do is you continuously check. So if you follow the CI/CD process, where continuous integrate, continuous deliver, deploy, you'll also continuous validate. So as new code keeps coming in, you keep checking for vulnerability. You do assessment. If it is vulnerable, go back to the drawing board. Not the drawing, go back to the code. Find out what the issue is, throw that back to the developer. The security team will sit and see what is the exposure, what is the vulnerability. They'll work with the developer to fix that. It again goes through unit testing, integrated testing, SAST, then dynamic testing, doing testing, and comes to staging. So the whole process has to be followed. That's one. Second is penetration testing and staging. One of the most important steps that we follow, right? Every time you deploy a new application, you deploy a new release, every time the code has gone through a change, you do a pen test. What is called a pen test, nothing but penetration testing, which means that you get third party, generally third party, to come and get into your network to see if they can get into your application. Basically seeing if your environment can be penetrated by external third parties. If it is, then you have a problem. There is a process called hardening your environment, hardening your infrastructure, hardening your application. 3 layers you will go back and harden. It's a long process, takes some time, but once hardened, it's very difficult to break into. So the pen test will tell you how vulnerable is your environment. This is like building a nice house and then leaving it open for robbers to come in and steal. Right? So you want to put the right mechanism. You want to put a camera, you want to put a lock, you want to put an alarm, you want a notification on your cell phone if somebody is tampering with your main door lock. So these are ways by which you are avoiding vulnerabilities of your property. Similarly, in a software, wherever you think there is even a small hole through which somebody can actually get in, you want to seal that hole. How do you seal that hole? You build controls around it, saying that, oh, for somebody to enter in this hole, they will have to pass through these tests or controls. And that's how you start tightening your grip and noose around the core infrastructure that you built. And the best way to do that is, how do you know how loose I am today? How open am I today? You do a pen test. Generally, organizations today, audit bodies today mandate that all enterprises should perform penetration testing at least once a year. Some of them do once a quarter, some of them do once every half year. But the general practice at least once a year. It's a slightly expensive proposal, and it's kind of time consuming, because guaranteed 1 out of 10 organizations will pass pen testing in the first attempt. This year you pass first attempt. Next year you will have 10 findings, guaranteed. as individuals, as human beings, we are not so strict when it comes to implementing changes. There will be lacks that we would have overlooked, because of which you will make your environment vulnerable. No, it could be your boss told, no, tomorrow feature has to go live. We'll do all the testing later on. First release, right? We promised the market release, parallel do your testing, and day after tomorrow we'll do one more release. Once released, I'll tell you the developers will go on vacation. 7 days later, when they come back, everybody has forgotten. 23 days later, when somebody hacks into your network and creates chaos, then you remember, oh God, we did not do the testing. Right? So the continuous vulnerability assessment is one part of the control mechanism. Second is pen testing to make sure that your environment is completely done, your application is completely or with minimal vulnerability or without any vulnerabilities. So that's how you will continuously validate security around your application infrastructure. Implementing DevSecOps in your organization, right? Develop a clear strategy, goals and metrics. Provide training for all your team members. Implement automated tool chain. I'm going to get to that in a little while. Integrate security into CI pipeline, monitor and improve continuously. So how do you implement DevSecOps in your organization? First is create a strategy. Now, generally, implementation of these frameworks like DevOps or site reliability engineering or DevSecOps or Agile or SAFe, all of this should be top-down, which means it should start originating from the CEO or the CIO of the company. It should go downwards. You don't want a developer to start implementing DevSecOps or DevOps, right? You will not know. The organization's head will have a broader outlook on how do I deploy this whole framework in the organization? How do I bring this change into my organization? So when you talk about a change at this level, a DevSecOps or a DevOps or an SRE or an Agile or a SAFe or a Scrum, there is a cultural change, cultural mind shift that your organization has to go through. So people are used to a certain way of working. You come back and suddenly make a change, people resist change. They have to have acceptance. So all that will have to be taken care, which can be done only when it is top-down. So first is develop a clear strategy, goals and metrics of how we want to do, what you want to do, when you want to do, why you want to do, where you want to do. You'll have to answer all the questions. And then start the implementation. As you implement, keep training all your team members, the new way of working. Then implement the automated toolchain. Automated toolchain is what you see on that. This is an example that is given, right? For source control, we'll use a GitLab or a Bitbucket. For continuous integration, you might use, in fact, CI/CD, my most favorite tool is Jenkins. For SaaS, you use SonarQube. For OWASP, dependency check SCA, container security scanning, we just saw that. For Checo, you use Checo for infrastructure as a code. For DAST, security integration test, release of product, you can actually use SonarQube itself. It's not a bad tool, in fact. So what you do is from a planning phase to the release phase, make sure that you've got tools that can automatically create flows for code to flow through from one phase to another phase after completing the necessary security checks. That can be taken care. I'm telling you, the environment can become absolutely safe. Now, it does not mean that you're hacker-proof. There still will be smart cookies who will come back and try hacking you. There are hackers who constantly attack you. Their only job is to make sure that for some people, hacking becomes a passion. They say, I don't want to achieve, I just want to make sure that I satisfy my ego of being able to break into the network. Once I break into the network, I'll just get out. I don't want to tamper around, create harm. That's one group. The second group, no, I want to make money out of this. The third group is to hack in and understand your business logic. How do you run business? What's your revenue strategy? What's your profit? So there are different groups that does hacking or breaking into your network for different reasons. And it is up to us how we want to protect the systems by implementing control, by using tools to make sure that all these controls are put in place. Right? The fourth one is integrate security into a CI pipeline. Now, when you've done a requirement gathering, you've done a design, high level, low level, you've created a bill of material, then you have build, which is you have developed software. Then let's say there are 3 groups of developers who develop software in their own branches. It goes to main branch in Git. you do a code merge there, then you do an integration testing. Now, after integration testing, it goes into CD, which is delivery mode. It goes to a production server or a staging server. Now, continuously, when you have a stream of code coming in, unit testing, then going to, you call it as continuous integration. So the CI pipeline is nothing but there's a constant stream of code that comes in from different developers on a continuous basis, keeps getting integrated, tested, going into CD. So integrate security. So even in CI pipeline, the pipeline that contains the code that is waiting to be integrated, implement security control there, try and perform security tests to make sure that there is no breakage even there. And lastly, monitor and improve continuously. So you will have to, when you monitor, the monitoring is basically done across your, ideally across your dev, test, staging, and production. In my own experience, consulting assignment that I've done, I have seen some organizations have come back and told me, hey, Ramesh, we thought we must monitor only the production. Why am I wasting monitoring tools, resources in monitoring development? So we say, let's say if one of your developers turns rogue, what do you do? How do you prevent that? How do you know? Right? You can hamper your whole environment. So it is so important for us to monitor all the environments, regardless of whether they are lower environments or higher environments. Lower environment here, I basically mean your dev and test, into maybe even stage. Stage is kind of a pre-prod. And then higher is the production environment. So you might have one monitoring tool across the enterprise or different monitoring tools for different environments. It all depends on how wealthy your organization is, how critical your business is, what is the ability of spend that your organization can adopt it. So that determines how do you really want to go back and monitor your systems and improve content. What does monitoring tell you? Monitoring tells you that is there something going wrong? If it is, you have to go back and fix that. It kind of alerts you that saying that something has gone wrong, please go back and fix that. Right? This is like if you go to a hospital and go to an intensive care unit, an ICU, you'll find a patient is lying down, and then there are multiple wires connected to his body. It's connected to a screen. The screen will keep on giving you bleep noise, right? And there are certain parameters, we call them as vitals, VITALs in medical terminology, where you monitor those vitals which are critical, crucial to the life of that patient, right? If any of them go down for some reason, the patient might die. Similarly, the monitoring, you may monitor 20 parameters, but you will make sure that the key ones that you're monitoring, the vitals for a software infrastructure, those generate alerts. That alerts will tell you that if I don't go back and fix that, the whole system could crash. So the whole concept of monitoring and improving continuously means that you constantly monitor your system and application and service to make sure that nothing is going wrong. Something is going wrong, you're able to go back and fix that instantaneously rather than having to wait to go back and fix that. The last slide in the presentation, which is measuring success. Now, everything that you've done so far is great. What happens? How do you know that what you've implemented is running successfully or not? We've implemented DevSecOps. What is the best way for you to know whether you're successful or not? A similar question could be your son or daughter goes to a school. They write their examination. How do you know that they've passed or failed? They get measured, right? They write an examination. Somebody evaluates the examination, gives them a score. It could be on 100 or on 50 or on 25 or on 10, whatever, right? Out of 100, the son or daughter scores, let's say 70, passed. Score 20, failed. So for you to know whatever you have done so far in terms of implementing DevSecOps, putting controls around your environment, whether it is running successfully or not, you need to measure that, right? And when you measure, what do you measure? How many vulnerabilities has my monitoring tool found out? How many vulnerabilities have I fixed? How fast have I fixed that? How many vulnerabilities came in production? Were these observed in development and testing? If not, how did it slip there? So you will do a lot of those. So the data that your monitoring tool provides will tell you the story, saying that, oh, last week we had 10 vulnerabilities. There were 2 hack attempts. 3 hackers came in, which means your tool is still low on controls. You got to go back and fix it. So the measurement typically tells you if you're doing well or not. If it tells you're not doing well, you have to go back to the drawing board, go back and fix it. If it says you're doing well, don't stop, improve it further. That's the most important fact, right? A lot of people say that, oh, I'm meeting all my controls. So don't relax. Go back and see if you can, because the moment you stay there saying that I'm meeting all my controls, tomorrow, why tomorrow? That evening, you will have a new hacker who will try and hack into your system or break into your system. So the point is measure to know where you are today, measure to know what to improve, measure to know how to improve. It also tells you why to improve, right? Now, some of the things that will tell you is number of vulnerabilities found and fixed before production. That's a success. Security incident response time, how quickly have you responded to your any security incident that have happened. Typically, if you look at an incident management process, I worked in my IBM life, I worked for multiple accounts, multiple centers, right? I've had some customers telling me, Ramesh, we will follow the general incident management and say change management process even for security. Some clients have come back and insisted saying that, oh no, Ramesh, we need a separate incident management process for security, separate change management process for security. They think it's important, key. They want to emphasize more importance on the security aspects. So security incident response time typically tells you that whenever a security incident happened, how quickly responded, how quickly fixed that. In a typical incident management time, we call it as MTTA, mean time to acknowledge, mean time to MTTR is mean time to respond and mean time to repair. So those are matrices that you will measure to know if the DevSecOps implementation that you have done in your organization has been done successfully and is running successfully. Security controls coverage. Now, it's a very important point. I'll spend about 2-3 minutes here. What do you mean? Security controls coverage typically means that how broadly does your security controls cover? For example, you built a house, right? And then you got three rooms in the house. Each room has a door, and then there's a main door, and then your compound has a gate. Now you could have a camera outside the house that could monitor the entire compound, and you can have individual cameras within the house to monitor the inner periphery of the house or within each of the rooms. You could have individual locks for each of the rooms inside the house. You could have a main door lock, you could have a gate lock, or you could have an automated lock with an alarm. So it all depends what is the coverage that you want to provide in terms of security for your code. So one is you can have individual control for each of the code set. Let's say there are 3 groups of developers who are developing code, Group A, Group B, Group C. Group A will have their own set of controls, Group B will have their own set of controls, Group C will have their own set of controls. And then when you do an integration, build and integrate testing, you'll again wrap one more control around. So the coverage that you're trying to provide to your environment, to your code, to your application, to your infrastructure must be deep enough to make sure that it's kind of layered one after the other. So it becomes extremely difficult for a breaker or a hacker because he hacks one level, he goes to the next level. Hacks another level, goes to the next level. Hacks another level, goes to the next level. So you're making it increasingly difficult for a hacker or a breaker to go in, or nobody can really break into your system. You create an environment or a wall around the system that becomes very, very thick and very, very non-invasive. That's the right term to use. So that way you make sure that your entire forte is covered. Now to top it up, the last layer, if I may use that term, of coverage should be your pen test. The moment you complete your pen test, look at all the... So pen test will be done at a different level. One is at an application level to know vulnerabilities, at a network level to know what are your open points, what ports are you open, how dangerous are they, at an infrastructure level. So when you get that holistic report, application level, infrastructure level, network level, go back and fix all of them, then perform something called hardening. Bring in experts. There are hardening experts who know how to harden your environment. They will harden, and during the course of hardening, you could probably they could end up doing a lot of testing. So the hardening of the environment, the whole environment, the surrounding environment of your network, the surrounding environment of infrastructure, the surrounding environment of your application, all of that together will make your application literally impenetrable, which means that it's going to be extremely difficult, 1 in 1,000 chance for a hacker to come back and hack into your application. So that, my friends, is what DevSecOps can do for your organization. And it can, the last benefit, if I may say, is, you have some system in place or a framework in place, implemented in place like this. Your CIO, CISO, why your CIO, CISO? Your developers, your operations teams, all of them can go back to sleep peacefully. They know that I have very strong environment. Now, are there no exceptions? There will be exceptions. You may be as strong as you like, but do you think people still can't break? There will be somebody who will come back and break that. But that's maybe, see, one in a 10 versus 1 in 1,000. That is the opportunity that you have to look at, saying that how difficult am I making it for somebody to break in? The more difficult it is, the more you're discouraging people to try, because they'll say, oh, I don't have to spend so much. There are other players in the market who I can hack in easily. Why they spend so much effort? Which means you're discouraging people to come and try and hack or break your network. I think with that, the session comes to a close. I'll pause here for any questions that people might have. Gigi, you can open up for people to ask questions in case if they have any.
Feel free to ask questions if you have any doubts. Thank you.